Okay, you guys, it's Mr. Moon here. Now we're going to have a quick conversation about parallel lines and perpendicular lines. So let's start by giving ourselves a coordinate plane because we are talking about graphing these in equations that give them to us. So I'm going to give myself a nice simple coordinate plane that goes to 4 or -4 in every direction. Very simple. And you'll see why I covered the concepts of multiplicative inverse and additive inverse as well. So this will all tie in together. So let's uh, let's first talk about the perpendicular lines, which is the harder concept. But you know me, I want to make sure you understand the harder concept, and the easier concepts are even easier to understand. Now I'll give you the hard stuff while I still have your attention. So perpendicular lines, the x-axis and y-axis are perpendicular to each other because they make these perfectly square corners where they meet. And that's what perpendicular lines are. Where they intersect with each other, where they touch, they make a perfect right angle, which is the same kind of angle you find at the corner of a square or a rectangle. Um, those angles are very important in a lot of mathematical concepts, but you know, it's easy to see that these are perpendicular here because you have one that goes perfectly horizontal, so it has a slope of 0, and one that's perfectly vertical, so it has an undefined slope. So yeah, that's great. But what if you have a line that isn't perfectly horizontal or perfectly vertical? How do you find a line that will be perpendicular to it? So let's start with a nice simple line. Y equals 1/2 x plus 1. So I know my y-intercept is at 1, so I'm going to put a point at 1. And then my rise is 1, and my run is 2. So I'm going to go up 1 and over 2 and put my next point. Then go up 1 and over 2 and put my next point. And I'm going to use those points to graph that line that should look something like that. Okay, so there's my y equals 1/2 x plus 1. In order to find a line that is perpendicular to it, makes a perfect right angle, I can see that this line has an uphill slope, so it's a positive slope. So I know I'm going to have a line that needs a downhill slope or a negative slope. But what is that negative slope going to be? I know it needs to be negative, but what exactly does it need to be? I have to apply the concept of multiplicative inverse and the concept of additive inverse. I need to put both of these inverses to the slope of this line. And we know that our slope is this term right here that's being multiplied by the input variable. We know that that's our slope. So I need to go ahead and apply the concept of multiplicative inverse and additive inverse to that. So first I'm going to do multiplicative inverse. So what number times 1/2 equals 1? So that's going to be the reciprocal. So I'm going to flip it around so I get 2 over 1. And we know that 2 over 1 is the same thing as 2. So now I've got that 2, but I also need to apply the additive inverse. So what I need to know is what number plus 2 will give me 0. And the answer to that, of course, is -2. So now I've already applied the multiplicative inverse, and now I've applied the additive inverse. So I know the slope for my line that will be perpendicular to this one is going to be -2. I can make the y-intercept whatever I want it to be, unless the question specifies what the y-intercept is, or if the question specifies they want it to pass through a specific point, and we'll get to that later. But what I can recognize is that my slope needs to be -2, so I can say y equals -2x, and let's just say -1, just to have a spot to go ahead and put it. So y equals -2x minus 1. So I'm going to put my y-intercept at -1, and my slope is -2. So I'm going to go down 2 and over 1. All right. So now I can go ahead and graph that line with this information that is given. All right. The lines intersect here, and where they intersect, we know we have right angles. All of these are 90-degree right angles because the slopes of the two lines, -2 and +1/2, are a combination of multiplicative and additive inverses of one another. That's how we find our parallel lines. All right, let's put that aside and let's look at parallel lines. Parallel lines means they're never going to touch each other. So let's again give ourselves a coordinate plane, a nice easy coordinate plane. 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so what we know is that parallel lines, it means they're never going to touch no matter how far you extend it. If this coordinate plane went out to 100 in every direction or 1,000 in every direction, those lines are never going to touch each other. So that means they have to change at the same rate. If we consider our input variable and our output variable and how they interact with each other, they have to interact the exact same way, which means the rise and the run, or the run and the rise, the slope, however you look at it, needs to be exactly the same. And of course, they cannot have the same y-intercept because that would be them touching at a point. So we can take any two, y equals mx plus b. We know the b's need to be two different numbers. So let's try a 2 and a -1. And let's make the slope for both of them 2/3. 2 over 3, 2 over 3. So the first one here has a y-intercept of +2. And I'm going to go up 2 and over 3. And then I'm going to have my second point. And now I can graph that line with those points. All right. Now let's look at the second one. Y-intercept is -1. And go up 2 and over 3. And that gives me another point there. Now I can go ahead and graph that line. And the concept is that because they will change the same amount every time you extend it, every time you plot another point that will be on this line, they will be the exact same distance from one another for that same input. So at the input of x equals 0, you can see that they are exactly 3 units apart from each other because their y-intercepts are 3 units apart from each other. Then at the point here where x equals 3, still the lines are 3 units apart from each other. And at any input, at any value you find for x, any value you use for x, these lines will be exactly 3 units away from each other for that point on x, which means they will never touch. Okay, so that is the concept of parallel lines. To summarize, if you want parallel lines, the m must be the same. The slope of the first line must be the same as the slope of the second line. That's what the little 1 and 2 here mean. The slope of the first line is m1 is the slope of the first line, m2 is the slope of the second line. All right. For perpendicular, hope I spelled that right. The slope of the first line, you have to find the multiplicative inverse, which means the reciprocal, and to the negative first power is a symbol for reciprocal. And then you have to find the additive inverse. And I actually don't know a symbol for that, but what I'm going to say is, matter of fact, let me do the additive inverse first. Let's say m1, the slope of the first line, plus the slope of the second line, the inverse of the second line must equal 0. There we go. Great. Yep. That's how you could write that. But you get the idea. All right. So see you guys in class. Take it easy. Bye-bye.